In this lesson, we're going to look at two more theorems that are fairly self-evident, and the proof for both of these theorems is very similar to the proof of Theorem 8, the addition property theorem. So I won't show the formal proofs, but I will show examples of both of the new theorems. Begin with Theorem 14. If segments or angles are congruent, their multiples are congruent, also known as the multiplication property. And this is another theorem that could be split into two theorems, one theorem for segments and the other theorem for angles. Well, our first example, we'll look at segments. And in this example, instead of talking about the segments being congruent, we'll talk about their measures being equal. But we know that congruent segments have equal measures, so we can just as easily talk about equal measures rather than congruent segments. And in this case, we're given that B and Y are midpoints, and AB is equal to XY. And among the conclusions we can make is that AB is equal to BC by definition of midpoint, and also XY is equal to YZ, also by definition of midpoint. And then, since AB equals XY, all four of those segments have equal measures. AB equal BC equal XY equal YZ. And then the final conclusion we'll make here is that the entire segment AC has the same length as the entire segment XZ. The next example involves trisection of angles. So we're given two angles, angle BAC and angle YXZ, and each one is trisected by a pair of rays, giving us angles 1, 2, and 3 on the left and angles 4, 5, and 6 on the right. We're also given that angle 1 is congruent to angle 4. Well, one conclusion then, because of what we know about trisection, is that angle 1, angle 2, and angle 3 are all congruent. And on the right side, angles 4, 5, and 6 are all congruent. And since angle 1 is congruent to angle 4, all 6 of those angles are congruent. And then this theorem allows us to conclude that angle BAC is congruent to YXZ. And we'll show the last one with arcs. Angle BAD is congruent to YXW, and also angle DAC is congruent to angle VXW. In Theorem 15, if segments or angles are congruent, their divisions are congruent, also known as the division property, and also a theorem that could be stated as two separate theorems, one for angles, one for segments. In an example of this theorem, we'll use two trisected segments. So we're given that AD is congruent to WC and that each one of those segments is trisected. The first one by points B and C, and the second one by points X and Y. Again, there's several conclusions we can make. The first one I'll make is that AB is congruent to BC, which is congruent to CD. And on the right side, WX is congruent to XY, which is congruent to YZ. And we can also conclude that all 6 of those segments are congruent because the original two segments, AD and WZ, were congruent. And now we'll do a problem where we're given an additional statement that AC is equal to 10. Among the conclusions we can make are that AB and WX are both 5, and if they're both 5, then the rest of those segments are also 5, as shown. The entire segments, AD and WZ, they're each 15. And we were given that AC is 10. AC is equal to BC, so it's also 10, along with WY and XZ, 4 segments that are 10 units long. In this lesson, we looked at Theorem 14. If segments or angles are congruent, their multiples are congruent, also known as the multiplication property. And Theorem 15. If segments or angles are congruent, their divisions are congruent, also known as the division property.